Hello guys, we'll talk about the operation of a bridge LAN. Compared to a hub, a bridge is more intelligent as it does not always have to repeat a received signal to all end stations connected to it. A bridge is capable of forwarding data frames received on its ports to the intended destination by reading the destination MAC address of the frame and sending out on the port where this end station is attached, based on a special database. This capability makes the bridge a Layer 2 device, as opposed to a hub, which is a Layer 1 device since it cannot read Layer 2 information. During the course of the presentation for the VLAN series, the terms bridge and switch may be used interchangeably as they primarily perform similar functions. However, both devices have some significant differences across hardware and software features. A bridge is designed primarily to process incoming and outgoing frames on a LAN. This processing can be seen from two perspectives. 1. The bridge as a relay, and 2. The bridge as a filter. As a relay, the bridge can process frames in three ways: by flooding, by forwarding, and by discarding. It is able to perform these functions by using a database called a MAC address table, where the mapping between MAC addresses of end stations and the attached port is stored as a dynamically generated or static entry. A bridge will flood a frame on two occasions. 1. If the destination MAC address of the received frame is the broadcast MAC address. It means the frame is meant for every end station connected to the bridge, with the exception of the end station that sent this frame. 2. A bridge will flood a received frame when a mapping for the destination MAC address of the frame cannot be found in its MAC address table. It will flood this frame with the assumption that it reaches the target end station. A bridge will forward a received frame to the intended end station only when a mapping for the destination MAC address in the frame exists in its MAC address table. It is important to note that after a bridge receives a frame, new MAC address table entries may be dynamically generated only based on the source MAC address. This is because it can easily learn this mapping even if it isn't present in its MAC address table, but it cannot learn the mapping for the destination end station except that this has been previously learned through a received frame on that port or through manual configuration. A bridge will discard a received frame if the destination MAC address is mapped to the same port on which the frame was received. This usually happens when a hub or another bridge is used to connect multiple end stations to that port. In this example, assuming that PC A has previously had a two-way communication with PC B, PC C, and PC D, the bridge will map the MAC addresses of PC B, PC C, and PC D to port 2. Note that the hub will always flood received frames. Therefore, if PCB sends a frame destined for PCD's MAC address, the hub will flood this frame as it cannot read MAC address information, and a copy of this frame will be received on port 2 of the bridge. The bridge will discard this frame as it does not send a frame from the same port on which it was received. Finally, as a filter, a bridge will enforce certain control policies which may override or utilize the existing MAC address table entries in processing frames. Some of these control policies include the access control list, virtual local area network, port isolation, and many more. The main focus for this series is to learn about the bridge as a filter for virtual local area network scenarios. More details on the concept of VLANs and its importance will be discussed in the next video. Please subscribe and share. See you in the next one, and thanks for watching.